All right, guys. So I want to take a little bit more in depth of a look just today, really at circles and ellipses. Again, um, I know we're oscillating back and forth, but we're just going slowly. So um, these are three examples of conic sections, right? We have a circle example here, an ellipse example here, and a hyperbola example here. And I put these in a calculator by putting in the two equations. So I had to put in y sub 1 equals square root of 25 minus x squared, and y sub 2 equals negative square root of 25 minus x squared. And when you see the picture, the way that you would describe somebody to draw this would be, okay, tell them the shape, circle, ellipse, or hyperbola. Where's the center of it? And what are the radii? So if you look at the circle, right, this circle, this equation made a center I wrote here of 0, 0, and the radius is 5. You can count 1, 2, 3, 4, 5 in every direction. That's what makes it a circle. And that would be a good way of describing to somebody what it looks like, right? This second equation here made an ellipse, which means it's elongated in some direction, okay? Again, its center is 0, 0. Now it has two different radii in this case, right? To the right and left is 1 unit, so it has an x radius of 1, and then up and down is 5 units, so it has a y radius of 5. But that's enough information to describe to somebody how to draw it, okay? So I want you to be able to look at that. This is about, today is about the center radius form, excuse me, which is a very important and easy to graph form for these, because it's all about translations and dilations. We're back, as always, to translations and dilations. This formula right here that you've seen before on the first day we did this on Monday, or Friday, was it? X squared plus y squared equals 1 makes a unit circle centered at 0, 0 with a radius of 1. So if I were to write that out as in its center radius form, right? Look, I could take this first term, x squared, and I could say that's the same as x minus 0, because that's x, divided by 1, still x. Subtracting 0, dividing by 1, doesn't change the fact that this is x squared. Same thing with y. Subtracting 0, dividing by 1, doesn't change the fact that it's just y squared. Something minus 0 divided by 1 is the same thing back, okay? Well, these subtractions and additions are the translations which describe the center. And the divisions or multiplications, as always, describe the dilation, which is the radius, okay? So when you look at a weird elliptical equation in this form of something, generally speaking, these are the three things that you have to look for in the center radius form. You first of all have to decide, because hyperbolas can look like this too, which we'll get into later. But you have to decide, is it a circle, ellipse, or hyperbola? And the way to tell that is the signs on the outside of them. Not the inside signs here, but in green, on the outside of them, okay? If they are the same, it's always going to make it a circle or an ellipse. Look, you can see that up here. Positive x squared, positive y squared. Positive 25x squared, positive y squared. They made a circle or an ellipse. But down here, positive x squared, negative y squared made a hyperbola. So if those outside, now you won't always have the plus there, but it's implied if it's not there, right? So if it's the same sign, it's always going to be a circle or an ellipse. If they're different, if this is plus and this is minus, or this is minus and this is plus, it's always going to be a hyperbola. Then find the center. Look at the translations. This is minus 4, which means a horizontal translation of plus 4. It's horizontal because it's associated with x. This is plus 5, which means a vertical translation of minus 5. It's a vertical translation because it is associated with y. So this tells you where the new center is. Plus 4 minus 5 is 4 negative 5 for the center. So when I go to draw this ellipse, I go 1, 2, 3, 4, and down 1, 2, 3, 4, 5, and I plot the center right there. Okay? and then find the radii. Look at the dilations. This is divided by 2, so it's times 2, horizontally on x. This is divided by 3, so it's times 3, vertically on, because it's with y. So the horizontal is the x radius of 2, the vertical is the y radius of 3. So from that center, we sketch this ellipse. 2 to the right, 2 to the left, put a point there. Up 3 from the center, down 3 from the center. And we have, it is elliptical. It's almost circular because they're almost the same. But we have an ellipse down here that looks like that. So that's what I'm going to ask you to try today, is take a look at some of these equations and sketch the ellipses in this way. Okay? Let me know if you guys have any questions.